error associated with any of these quantities are always added and not subtracted. There is no point of subtracting there. Okay, since you have added here, yes, of course you have to add this. The absolute error in the final result is the sum of absolute error in the individual quantities. The final error, whatever we get, is termed as absolute error. Hello everyone, I'm Brinda, Faculty of Physics from Vidhyaashram Pre-University College, welcoming you all to session 4 of chapter 2, that is units and measurements. So in this chapter, today we are going to study combination of errors and its numericals. As you all know, in our previous class we have studied regarding errors, right? The errors were of two types, that is systematic errors and random errors. Out of which in systematic errors, again there are three branches, that is, one is imperfection in procedure, another one is instrumental error, as well as the third one is personal error. In detail in my previous class I have told you regarding the errors. So coming to combination of errors, how do you tackle with the combination of errors? So that is what is told in this session. So here the combination of errors for the mathematical operations, there are three types. There are three procedures in order to follow this combination errors. So here one is error of sum or difference. It is error of sum or difference. That is the very first subtopic under combination errors. So the second one is error of product or a quotient, and the third one is error in the case of measured quantity raised to a power. So these three are the rules to be taken in order to tackle with the combination errors. So each and every rules are studied in detail as follows. That is, first one, the very first one is error of a sum or a difference. The very first rule in combination of error is error of a sum or a difference. So error. So what is that error? As I told you already in my previous class, error, it is the uncertainty in the measurement. It is the uncertainty in the measurement. So error of a sum or a difference. So here it is either we are looking into the error of a sum, that is addition, or error of a difference, that is subtraction. So you can either add a quantity or subtract a quantity, adding a quantity or subtracting a quantity, and the error associated with any of these quantities are always added and not subtracted. That is what is there in this rule. Either you take up addition or you take up subtraction. So adding a quantity, its error is said to be added itself, and if it is subtraction, you are taking it, considering the error of a subtraction of that quantity, you are considering error of the same quantity, but the quantity is being subtracted here, but its error is not told to be subtracted. According to the rule, it has to be added. That is what it is. When two quantities are added or subtracted, the absolute error in the final result is the sum of absolute error in the individual quantities. Again, you can read the statement. When two quantities are added or subtracted. Just imagine if x is my quantity plus or minus delta x is the error of one quantity. This is my first quantity. Consider the second quantity. Let it be y plus or minus delta y. So this is the absolute error. Delta x is the absolute error in the first quantity and delta y is the absolute error in my second quantity. So this is said to be, it is a second quantity. So there are two quantities. So when two quantities are either added or subtracted, either it can be added or it can be subtracted, the absolute error in the final result. So which are the absolute error here? So what you do, you just add these two quantities, that is you just add x plus y. If in the case of addition, if you're considering the case in which addition is taken, so then it is x plus y and your delta x plus or minus delta y. Right? Similarly goes with the subtraction, that is x minus y plus or minus delta x plus or minus delta y. So this is the error in the answer whatever you're getting. So it is a result. So when two quantities, these two quantities are either added or subtracted, anything either added or subtracted, the absolute error in the final result consists of the absolute error. No, it is always said to be the sum of absolute error in the individual quantities. It is sum of, there is no point of subtracting there. Okay, since you have added here, yes, of course you have to add this absolute error with this absolute error. Since you have subtracted here, is it that you have to subtract this absolute error with this absolute error? No, it is just that you will have to add the absolute error in the result. So that is what the statement says. When two quantities are added or subtracted, the absolute error in the final result will be the sum of absolute errors in the individual quantities. So I hope you all understood how to go on with the rule. So in order to understand this in a better way, I am solving an example numerical here. So coming to the numerical, the temperature of two bodies measured by thermometer are T1 is 20 degrees Celsius with plus or minus 0.5 degree Celsius. So my absolute error is this 0.5 degree Celsius. And T2, the second temperature with the same thermometer it is measured. So the second temperature is 50 degrees Celsius plus or minus absolute error is 0.5 degree Celsius in the same thermometer. So calculate the temperature difference and the error. We will have to calculate temperature difference and the error. So given terms, I told you while solving the numericals, you will have to write down the given data and which formula to be used. If the formula is given there or a formula you have to get it from the theory part, it is left to you. It is according to the problem. So it is all that you have to first of all visualize the question, read the question and write down the given points. So coming to given, you have got first temperature that is 20 degrees Celsius with plus or minus 0.5 degree Celsius. And the second temperature with the same thermometer is measured as 50 degrees Celsius plus or minus 0.5 degrees Celsius. We will have to calculate the temperature difference. That is, you have to subtract the quantity. You will have to find out the temperature difference. So this difference is nothing but subtracting the quantity. One quantity with the other quantity and you have to find out the error. So what and all you have to find out? It is the temperature difference and the error. So let us solve the problem. Solution. So it is T is equal to T2 minus T1. So what is T2? Substitute for T2, that is 50 degrees Celsius plus or minus 0.5 degrees Celsius minus 20 degrees Celsius plus or minus 0.5 degree Celsius. So you will have to consider this, the temperature of the quantity first, that is 50. Since they have asked you temperature difference, you will be subtracting 1 degree Celsius with the second temperature, that is 20 degrees Celsius. It is 50 minus 20 degrees Celsius plus or minus 0.5 degrees Celsius plus or minus 0.5 degrees Celsius. So 50 minus 20 gives you 30 plus or minus. According to the rule, it is that sum of absolute errors, that is final result is the sum of absolute error in the individual quantities, that is summing up of the absolute errors in both of the quantities. So here 0.5 degrees Celsius I have taken from this quantity. Again 0.5 degrees Celsius I have taken from this quantity. So 0.5 plus 0.5 gives you 1 degree Celsius. So 30 degrees Celsius plus or minus 1 degree Celsius is the temperature difference and the error in the experiment or the given observation. So I hope it's clear. The first rule is clear. So what does the first rule says? It is when two quantities are added or subtracted, the absolute error in the final result is the sum of absolute error in the individual quantities. So coming to the second rule, that is error of product or quotient. Error of product or quotient. In your first rule, we had studied error of addition or subtraction. In this case, we'll be studying error of product or quotient. So, when two quantities are multiplied or divided, the relative error, when it comes to multiplication or division, the result error, or the final error whatever we get, that is called as relative error, that is termed as relative error. In case of addition or subtraction, the final error whatever we get is termed as absolute error. So when two quantities are multiplied or divided, the relative error, that is the error is called a relative error. The relative error in the result is the sum of relative errors in the multipliers. Remember, it can be multiplication or division, but the error is always added up. Okay, it is the sum of relative errors in the multipliers. Same thing, it is the same rule carried on for multiplication as well as division also. So when two quantities are multiplied or divided, the relative error in the final result will be the sum of the relative errors in the individual quantities or the relative errors in the multipliers. Okay. In order to better understand this one, let us solve a numerical, that is the resistance R is equal to V by I. You all know this is from the Ohm's law. Okay, the resistance, this equation you already have studied in your 10th standard, Ohm's law, and R is equal to V by I. The resistance is equal to voltage by current. So it will be studied in detail in our next upcoming classes. So here we have the resistance given as R is equal to V by I, where V is equal to 100 plus or minus 5 volt. Voltage is already given. And I, that is current, is equal to 10 plus or minus 0.2 is your relative error, 0.2 ampere, and we will have to find out the percentage error in R. What we have to find out? Percentage error in R. So how to go on with this? So as you all know, here they have given the absolute errors and the percentage error has to be calculated in R. So what we are doing is we are considering the relative error first. As you all know, you have studied absolute error, relative error as well as percentage error in our previous class. The same formula goes up here. That is relative error, it is nothing but delta A mean divided by arithmetic mean of the quantity which we had taken. The same thing goes up here, that is the error is calculated first, that is 5 divided by 100 into, since we are calculating percentage error in R, it goes up like delta V is equal to 100. So this cancels with this because this is percentage, 100%. So it is 5%. It is the percentage error in V. Similarly goes with percentage. What is the percentage error in I? So percentage error in I is calculated as, you're taking this ampere, that is 0.2 divided by 10. It is the quantity, the value of a quantity, into 100%. So you get it as 2%. So this is the percentage error in voltage and this is the percentage error in current. So what they have asked is find percentage in R, error in R. So we have got R is equal to V divided by I. So what is your V? It is 100 plus or minus 5 volt. And what is your I? It is 10 plus or minus 0.2 volts. So since we are calculating the percentage error in R, it is, as I told you, V. So the percentage error is given like this, plus percentage error of I is given like this. So I hope you're clear. Y plus, I could have given divided by, but Y plus, even though if it is multiplication or division, the relative error, the final relative error in the result is always sum of the multipliers of the individual quantity. So which is equal to, I can write 5% plus 2% on the whole, it is 7% error for R. So you have got R is equal to 7%. This is how you solve. I hope by this numerical you're clear with this statement. When two quantities are multiplied or divided, I could have divided here 5 divided by 2, but why I am not dividing? That's because according to the rule, it is summed up. The percentage error of the multipliers from each quantity is being taken and it is being summed up, and the total value whatever we get is 7% of percentage error. So coming to the next numerical, based on the same second rule. That is, if two resistors of resistance R1 is 100 plus or minus 3 ohms and R2 is 200 plus or minus 4 ohms, they are connected in series and in parallel. We will have to find out the equivalent resistance of the series and parallel combination. We have to find out equivalent resistance of both the combination, wherein they have given certain formula to be used, which I have not mentioned over here. I'll write it down. Please note it down. For series combination, we use RS is equal to R1 plus R2. For parallel combination, we use RP is equal to R2 R1 divided by R1 plus R2. So this is how we use the combination thing, which is already given in your textbooks. We all know given terms are R1 is equal to 100 plus or minus 3 ohms. R2 is equal to 200 plus or minus 4 ohms. So these two are the given terms. We will have to find out equivalent resistance for series as well as parallel combinations. Okay. So the thing is, first of all, you will have to write down for series combination. So it is for series combination, R1 plus R2. That is, for series combination goes up like 100 plus or minus 3 ohms, that is this R1, and R2 is plus 200 plus or minus 4 ohms. This ohm, it is the unit of resistance. Ohm is the unit of resistance which is determined, given by the symbol OM, ohms. Okay, ohm. So 100 plus 200 gives you 300 plus or minus. You're summing up these two. So 3 plus 4, 7 ohms. So 300 plus 7 ohm, that is the equivalent resistance of the series combination with certain error, absolute error, that is 7 ohm. So now coming to the resistance in case of parallel combination. So we are done with series combination. So secondly, for parallel combination, this is for parallel combination. How it goes? So we already have parallel combination formula as R2 R1 divided by R plus R2. This is how it goes. So let us consider this. This is the formula only to calculate the equivalent resistance. So when it comes to calculating its error, a term is introduced and that term is called as delta. The term is introduced and that term is referred to as delta. So delta is the one which gives out the error, which points out, yes, this is an error. It is associated with certain algebraic term or numerical term which is called as errors. Okay, so it goes up like this. So according to us, we know that relative error, it is nothing but you'll have to give the absolute error divided by the original actual quantity. So you can write this as delta Rp divided by Rp square, which is equal to delta R1 divided by R1 square plus delta R2 divided by R2 square. This is the error divided by actual quantity. Again, error divided by actual quantity, error divided by actual quantity. This is how it comes. So now this can also be written as delta parallel combination of resistance into delta Rp divided by R1 whole square into delta R1. So this is one term, that is by taking this Rp square towards here, Rp divided by R1, since square and square, you're making it as whole square into delta R1. Similarly, it goes up with this, that is Rp divided by R2, both whole square into delta R2. So this is the second term. On substituting for parallel resistors divided by this parallel resistor R1 and delta R1, let us substitute and see what are we getting. So it is delta Rp is equal to, what is this Rp, what you're getting? Equivalent resistance. Let us calculate the equivalent resistance of parallel combination which we are getting here, that is R1 R2 divided by R1 plus R2. So excluding the errors, we are calculating only the actual number, that is 100 into 200. You get 100 into 200 divided by 100 plus 200 gives you 300, wherein you have 66.6 ohms. That is in parallel combination you get 66.6 ohms. So Rp is 66.6 ohm. The same thing is being substituted here. 66.6 divided by your R1 is 100. So it is 100. The whole square into delta R1. So what is this delta R1? It is 3 ohms. Error in the first resistance. So error in the first resistance is 3 plus, you have got again Rp as 66.6 ohms divided by R2 is nothing but 200. You will have to square the complete one into delta R2. It is the error in the second resistance, that is 4 ohm. So it can be 4 ohm. So on simplification, when you divide this and square this and multiply with this number, again divide first these two, then you will have to square it and then multiplying it with this number, final result what you're getting is around, this will turn up like 1.33 plus this will turn up like 0.44. So it is like 1.77. So delta Rp is 1.77. It is ohms. So this is the final result of the error of parallelly connected resistance. So on the whole, find the equivalent resistance of the series and parallel combination. So together we can write it as 66.6 plus or minus 1.77 ohm is the complete resistance of the resistors 1 as well as 2 in case of parallel combination. Here you have already done in case of series combination. This is in case of parallel combination. So now first rule is over, second rule is over. Now let us study regarding the third rule. That is, the relative error in physical quantity raised to a power k is k times the relative error in the individual quantity. So if you have got any quantity raised to some power, then the answer will be that power times the same quantity. If there is a question of finding out the relative error of this term, so a to the power of x, b to the power of y and c to the power of z. If this is the question where you will have to find out things, so relative error in a physical quantity, if the relative error, this error in this physical quantity is raised, consider x as a relative error in physical quantity A. So if the relative error in a physical quantity is raised to the power, that it is raised above the head, superscript, okay, raised to the power k. Here they have considered k. It can be x or any other numerical terms, whichever you want to put. So power k is k times the relative error in the individual quantity. So it is x times the relative error of this quantity A. So I can rewrite this according to this rule as x into A. X times the individual quantity, power times the individual quantity plus power times the individual quantity, again plus or divide. It is plus or divide. According to the rule, even if it is division, it has to be addition. The relative error, always the error comes up like sum of errors. Got it? Sum of errors as we had studied in the previous rules. So again it becomes power times the individual quantity. So x, y, z are nothing but power k. So it is k times the individual quantity. So if it is like a to the power of k, then it is k times the individual quantity. This goes here. Got it? This is what this rule says. To be clear with this rule, let us solve a numerical problem, that is, find the relative error in z if z is equal to a to the power of 4, b to the power of 1 by 3, c into d to the power of 3 by 2. So this is already given. There is nothing extra to be written like given so and so. This is already given over here. So let us directly come into this solution. According to the previous rule, it is K times the individual quantity. So Z can be written as 4 into A plus 1 by 3 into B plus 1 into C plus 3 by 2 into D. So this is what your previous rule tells you about. So coming to the other numerical, that is the period of oscillation of a simple pendulum is T is equal to 2 pi root Lg. You all know simple pendulum. That is, for a thread is being suspended and a bob is fixed. A bob along with the thread is suspended and here it is clamped. One end of the thread is being clamped. So what happens when the bob is made to move from A to B? It undergoes oscillation. What is that oscillation? It is a to and fro movement of a body. So it oscillates, right? So the period of oscillation of a simple pendulum is given by T is equal to 2 pi root of L divided by G. So measured value of L is considered to be 20 centimeters, known to have 1 millimeter accuracy. And time for 100 oscillations of pendulum is found to be 90 seconds. For 100 oscillations, the time taken is 90 seconds using a wristwatch of 1 second resolution. Of which one? 1 second resolution. Okay. What is the accuracy? We will have to find out the accuracy in determination of this G. Okay. So the thing is, first of all, you will have to write down the given terms. It is like you have got your L as 20 centimeters and 1 millimeter accuracy. So 1 millimeter can be converted into centimeter as 0.1 centimeters. Okay. So this 0.1 centimeter is the accuracy, no? So this is the original value. So its error comes up like delta L is equal to 0.1 centimeters. So this is my first term and this will be my second term. Coming to the third term, time for 100 oscillation. Now we have to get the other quantity, that is time. Time for 100 oscillation of a pendulum is said to be 90 seconds. So that I can write my T as 90 seconds. Using a wristwatch of 1 second resolution, again here the delta T comes up like 1 second resolution. So what is the accuracy in the determination of G? To find is the accuracy in finding determination of this G. So that when you take up G, what you have to find out here? It is G that you have to find out. So your formula becomes G is equal to, this G stays up here, so it is 4 pi square into L divided by T square. This is the formula to find out G. So now, since these two are the errors, that is delta L as well as delta T are the errors, it can be termed by plus or minus. Plus or minus has to be given over here. Now, taking this formula, let us proceed further. We'll have to identify only the errors. See here, this 4 pi square, it is always a constant term. So there is nothing to do with this so-called errors. We can't bring errors in the constant terms. So L and T, it is a variable thing. So we can give error in those terms. So we have got error for L as well as error for T. So now, how we proceed with that? So it is G is equal to 4 pi square divided by T square and here comes L. So in order to find out the error, what do we do? That is, use the relative error concept. G is equal to delta L divided by L plus delta T divided by T. Since it is T to the power of 2 according to the rule, something raised to 2, it is that times the quantity. So it is 2 times delta T divided by T. Okay, so now delta L. So what is the value of delta L, whatever you have got? That is plus or minus 0.1 divided by value of L is said to be 20 plus 2 into delta T, that is plus or minus 1 resolution, and the time taken, the T is 90 seconds. So on simplification, you get delta G by G as 0.027. 0.027. We have delta G by G. So this is the relative error. So we will have to calculate the percentage error of this. Percentage error of this is nothing but into 100 of the relative error. Whatever relative error you are getting here, that is delta G by G, it is a relative error, into 100% gives you the percentage error. So we calculate percentage error is equal to delta G by G value is 0.27, that is relative error into 100%. So we get 27%. So this is your percentage error. So you get 2.7% as your percentage error. We can approximate it to 3% is your percentage errors. So this is how we go with the errors, combination of errors. How do we combine errors in certain mathematical operations? So I hope you're clear with combination of errors. There are 3 rules. For addition as well as subtraction is first rule. For multiplication and division, it is the second rule. And something raised to the power, that is your third rule. I hope you're clear with all these 3 rules and numericals based on these 3 rules. Here, I'm winding up my session. So in the next class, let us see regarding the significant figures. So thank you one and all. Have a good day.